Hey there, I was working on this 6-people team project and we had to create a game from scratch. And there was this one mistake that many of my teammates kept making over and over and over again, and it had to do with one, missing the point, and two, getting lost in details. And that got me to wonder, how do you actually write good software? I mean, to me, and it will sound very braggy, is sort of automatic. But I think it's a skill that you can definitely pick up on. It's a skill of always going to the point and not pondering around insignificant details. It took me many, many years of trial and error trying to figure it out, but I think I can help you shave off a couple of years of that. You see, we were given a task of creating a video game. Everything was free-floating, loosely defined. So put yourself in our shoes. You have to design an entire engine, an entire code structure, an entire game, and you have to make sure nothing goes off the rails. And it's the first time any of you are working on a project of such scale. How do you do that? If you've ever looked into software engineering, you will have heard of stuff like UML, CRC, Moscow, user stories, all that stuff. I'm not going to explain it, but they're all some random nonsense being pitched as go-to ways to write good software. But the truth is that none of that matters. None of them are a one-size-fits-all approach. Because it's just something someone came up with and that worked for them. And if you understand the way all of these techniques try to solve the problem of writing good software, and like all the commonalities they share, I can guarantee you will become a 10 times better programmer. Which leads perfectly to the video we saw titled The Black Box Method, How to Learn Hard Concepts Quickly. And I completely agree with what Colin talks about in the video, and you should totally check it out, but if you don't, that's fine, I'll try to explain it as best as I can. The twist I'm going to take here is that instead of taking what Colin suggests to do in terms of learning stuff, we will apply it for creating new stuff. So, what do I mean by that? Well, essentially there are two schools of thought when learning stuff or creating new stuff, and they are the first principle school and the big picture school. The first principles is something employed by many successful people like Elon Musk, and is usually found in our school system. It's essentially taking a concept and breaking it down to the smallest pieces possible and then analyzing them one by one at the smallest scale possible. For instance, Elon gave a really good example when it comes to manufacturing batteries and the cost of them. And he said something like, okay, the raw materials are very cheap, but it's this particular process that's costing a lot, and that inflates the price of the battery. Okay, so how can we make this particular process 5 times cheaper? And it's a really great way to look at things if you want to deeply understand something, and if you want to find a fatal flaw in something, or if you want to improve something, and it's really cool, but it's going to lead you nowhere and waste a lot of time if you want to create something new. Take Elon, for instance, and it will trigger some of you, but he hasn't really created anything new. Electric cars date back 100 years. Hell, we've had electric trolleybuses in Lithuania for half a century. And reusable rockets, they're nothing new either. They're nothing new. But what he did do, though, is take unfinished, unpolished concepts, ideas, and make them viable, easy to use, and so on. And that is wonderful. And that is what we need. But how do you create new stuff? This is where the big picture school comes into play. Have you ever thought why artists first start with a rough sketch of a painting and then go on and fill in the details, make it more and more and more detailed. Well, now that I ask you, it's very simple. It's because, well, they don't know where a particular detail is going to be placed until they see the big picture. So, do you know where a particular code detail is going to be placed until you know the big picture? And what even is a big picture when it comes to coding? Well, it's the API, the public API to be precise. And tell me, why shouldn't we just copy artists? And what would happen if we went ahead and started with a rough public API? I'll use our game as an example. Take our Vulkan renderer. It's over 5,000 lines of ugly Java code. And it all can be abstracted to 3 main functions. Well, what do I want my renderer to do? Well, I want it to render stuff. I want to render a list of objects from some point of view. And this is the function I defined, and later on I only added this additional list of lights for lighting information. But that is the very essence. And then I also want to somehow create a renderer, so it will be a constructor. And after vulcaning a little bit, I also realized there is onResize thing that I need to call whenever a window resizes. But that's it. That's the core API, and that is the thing I came up with a literal month before implementing it. During that time, I went through a bit of a first principles time, going through the, Vulkan tutorial. I went through the Vulkan tutorial, I implemented some sort of renderer, and eventually after some time I said enough is enough, it's time to go ahead and make it fit the API. And I think that's the main thing that many beginners get wrong. They often start with the implementation, they make something work and it's alright, and then they build some API on top of it. And if you were to go ahead and look from the user side, you would notice that whatever you wrote works like rubbish. And that's what you should try to avoid. An example of things going badly would be our networking code. I've done networking in the past, I didn't want to be in charge of it. So I'm not going to give names, but one of our teammates took up the job. He's actually a really great guy with lots and lots of potential. He's got that lazy programmer quality, which is a good thing actually, trying to automate things, learning new tech and all that stuff. And he will achieve great things once he learns to stop for a bit before doing things and create a rough plan of what needs to be doing before jumping in and doing it. I wrote a rough outline of how secure network architecture should be laid out, and I linked him to my old project, which is not perfect by any means, but he had enough resources to go off of and write a solid networking base. And then he just went ahead and did his own thing, which absolutely didn't work. Now, don't get me wrong, I can commend experimenting with stuff, but we had a very, very limited time frame. So the implementation was inefficient at best. It would break spectacularly with user-controlled values, and overall it was not clean code. It was all just, glued together, safe to say. So eventually what I had to do, I ended up reworking the code. I first ended up making it work, then I cleaned it up, then I fixed all the bugs, and eventually when we had to do the documentation of our project, I looked at the doc, which is right here, and then I looked in our networking code, and they were almost one and the same. So this could all have been avoided if, he just spent a little time trying to understand the API, trying to, ask any questions if he didn't understand something, and, like, work it out together. But instead, we just wasted a lot of time reworking it over and over again. Now I understand thinking is hard, but don't underestimate it. It actually is very, very hard to think. But if there was just one point where you could just stop and think for a bit, it should totally be the part where you define the public API. Afterwards, feel free to go automatic mode, and that's exactly what I do. I first define an API, and then I just implement it, try to make it work. But I never skip the first step. And you shouldn't either. Use, pen and paper to draw the structure. Hell, use UML, you write user stories, list requirements using Moscow, write CRC cards, and do anything that helps you to define the API. And that is the whole point of those frameworks and tools. For me personally, I just usually write the CRC cards, which list the class, the functions, what it collaborates with, and I usually just take a piece of paper and just draw a bunch of random diagrams. And if defining the public API doesn't give you enough clarity, then you can go one layer deeper. For instance, back to the renderer, here are all the steps of creating a Vulkan, initializing a Vulkan renderer. Go ahead, define them, and then just go ahead and implement it. And if it's still not clear, then go even one layer deeper, peel it off, just one by one, until it gives you enough clarity. But make sure what you do works for you, and don't do things just for the sake of doing them. Don't miss the point. And if you enjoyed the video, don't forget to overflow the like button. It helps the channel absolutely tremendously, and hit subscribe for more content like this. I hope you learned something, and if you have any questions, pop them down in the comments below. And I really, really hope I see you very soon. Don't forget, my name was Heap. Yours was undefined. See ya.